Morning guys, it's Miss Nickerson. Today I'm going to walk you through the steps to putting together your DNA classroom model. I'm just reminding you that this does not require expensive materials. You can use materials you have at home. You can get some from me, paper, toothpicks, cardboard. What you make it out of is not nearly as important as do you construct it correctly and do you understand its structure. Today I'm going to walk you through the steps. It's early in the morning here. My son is sick, and if I can build this in about half an hour, I think you can build it over the next 2 weeks. It's going to be due in a couple weeks here, so follow along. One of the first things that I did this morning was gather supplies that I had around the house. So I happen to have some old craft foam, felt, some pipe cleaners. I've got scissors. I had a hole punch I may use later. I've got a paper, markers for kind of outlining my design. Then I found some construction materials. I've got a glue gun, found some glue tabs, and some old-fashioned traditional tape. I also found a bag of like old foam things from when my kids were little. I'm going to try to use some of those. So it doesn't really matter what you've got. I'm going to probably go grab some toothpicks out of the kitchen as well, see if I can put this together. The next thing I need to do is familiarize myself with the actual structure of DNA and RNA. I'm reminding that I've got DNA is made up of two sides. It's going to twist in a double helix as it goes up. It's made up of a nucleotide that's made up of a sugar, deoxyribose. It's a 5-sided sugar, phosphate group, and a base. And those bases are A, T, C, and G, and their shapes kind of determine the placement and how DNA is organized. So let's talk about their shapes again real quick. I'm reminding you that both adenine and guanine are what we call purine shapes. They're made up of two rings, a 5-sided ring and a 6-sided ring. And when attached to their complementary base pair, cytosine and thymine, which are made up of single rings called pyrimidines, 6 sides each, they make the steps that go across the DNA ladder. Also reminding you that when we talk about RNA, RNA has uracil in place of thymine, and it is also a pyrimidine shape, 6-sided. So when we put it together, we have to consider the sides of the nucleotide as well. So deoxyribose is the 5-sided sugar that makes up DNA, and ribose is the 5-sided sugar that makes up RNA. So considering the shapes as well. When you put it all together, you've got your base, which is either a purine or pyrimidine shape, a 5-sided sugar, and then holding those sugars together is a phosphate group. Notice how the phosphate group has 4 oxygens, and it kind of looks like an X, and so that's what I'm going to use in my model to signify the phosphate group. Okay, so I've got a couple of my pieces cut out. I've got my 4 bases, A, T, C, and G. And notice they match the purine and pyrimidine shapes. I've go ahead and labeled them, show how they have 6 sides and 5 sides. I've also decided what I'm going to use for my hydrogen bonds. I cut some points off some stars that I had in my bag. And I'm reminding myself that A and T are held together with 2 hydrogen bonds, and C and G are held together with 3 hydrogen bonds. There's a couple other parts I'm going to need to complete this. I'm going to need the rest of my nucleotide, so it's going to involve a sugar. And so when I'm building my DNA, I'm going to use a deoxyribose, a 6-sided sugar. When I'm building my RNA, I'm going to use ribose, also a 6-sided sugar. I'm going to use my phosphate group. I decided to use, this is my phosphate group to represent how it has a PO4 shape. And I'm reminding myself that when I get ready to make RNA, I'm going to need to replace thymine with uracil. So I went ahead and made a piece for uracil as well. One of the things you can do when you're cutting these pieces, either out of paper, again, or craft foam or cardboard, is take a piece, and once you get a good piece that you like, go ahead and lay it down as a template to cut the remainder of your pieces. It makes it a little bit faster, and then you've got them all a pretty uniform shape and size. You can also make these all out of white paper and color them, or construction paper, bottle caps, you name it. It doesn't really matter what you make it out of. I'm just making it out of something easy to cut today to show you my example. Take a moment to look at the model that you have on your desk and see if you can identify A, T, C, and G, deoxyribose, ribose, phosphates, and the hydrogen bonds. Models, part of the grading is that it has a key, so there should be a key attached to it as well. Now, I'm not saying that the models in my classroom are all A+. They're not. I kept them because they were all good examples of different ways to build the DNA models. You may find some errors in them, but see if you can pause the video and see if you can find those different components on the model on your desk. One of the best ways to start out building your model is to build it flat on the table like a ladder. So now that I've got my sugars and phosphates, I've decided to use some pipe cleaners for my sides, and I cut a couple pieces of felt for the center because that's what I had at home. So I have my alternating groups of deoxyribose, phosphate, deoxyribose, phosphate. Notice how the deoxyribose are a big molecule. It's one of the biggest components of the DNA molecule. And the phosphates sit outside of the sugars in our model of DNA. So across the center here, I'm going to construct my base pairing. For this example, I am using the 3 bases CAT on one side of DNA. So I'm going to assemble those, and then I'm going to see if I can correctly base pair match those bases on the other side. So let's see what that's going to look like. Okay, so I have correctly constructed the first 3 bases of my DNA model. On one side it reads CAT, and its correct base pair on the other side reads GTA. Notice I put the correct number of hydrogen bonds between our 2 bases, where A and T are held together with 2 hydrogen bonds, and C and G are held together with 3. I got myself a little key that I can use later, and I've got my sugars and phosphates alternating with my bases adjoining to the sugars and the phosphates sitting outside of the bases. Your model is going to be 12 bases total tall. So I've done the first 3. So you would continue this pattern up for 2 more sets of 3 until you get the very top of your DNA model. At the very top of your DNA model, we're going to replicate DNA replication and the creation of RNA. So next up, I'm going to do the top section here so you can see how that's going to be set up. Okay, so remember, your DNA model is going to be a total of 12 bases tall. I've just shown you how to do 3 example ones, starting from the bottom and reading up. Let's pretend we've got a few more in between here, but then at the top of DNA, we're going to split DNA. It's going to unwind and unzip. So on the top, you can see how our 2 original strands of DNA here and here have unwound and unzipped. And on the inside, we're going to build some replicate some more DNA as well as some RNA. I'm going to focus on the RNA side here for a second. So here's my original strand of DNA, and opposite I have my strand of RNA. RNA has 2 key differences in construction wise, actually 3. The first is it's just single stranded, so this is all that's going to be built. It has ribose instead of deoxyribose, so notice how I have a different colored sugar, and it has uracil in place of thymine. So although we have an adenine on our DNA side, its base pair is uracil on the RNA side. Here, however, thymine is still just fine because it's on the DNA side, base paired with adenine. Still 2 and 3 hydrogen bonds holding ours correctly together. We will only be replicating the top 3 bases for RNA. We'll be creating, transcribing the top 3 bases into RNA. The rest of it is just going to be our strand of DNA. So DNA now coming up on this side, we would continue to build with our letters that I required and then correctly base pair match over into a complementary strand of RNA, of DNA, that we're going to be replicating. So we're opening it up, and at the top you're going to show me that you understand how RNA is made, and you're going to show me how we understand how we're going to continue our DNA strand. Okay, this is the basics for you guys. Again, this isn't the whole model. I've only done 6 total. Yours will be a total of 12. And I've used materials that I have at home, but I made it a little bit larger than I normally would so that we could see details in the video. You're welcome to use just plain old white paper. Label the paper, color it. I have pipe cleaners available in class for anyone who would like it. You may use my glue guns and check them out and take them home for construction. They shouldn't be difficult for anyone to put together. Based upon materials you have available. Come see me if you're worried about materials and we can make it work. This is not an assignment that should be completed the night before it's due. It's going to take a little while. Once it's all the way constructed, you're going to need to make it so that it stands or hangs upright. So look at the examples that I have in class and see, look around the room. What are the different ways that they were able to make their DNA model actually stand up and be viewable in class? I hope this helps you guys get some ideas. You can start gathering supplies this weekend. I'm going to give you a little bit of extra time because I'm gone. And now we kind of know how we're going to put together the DNA model. Thanks.